Today we will continue with the nonlinear data structure tree with its more features. We discussed up to the different traversal techniques in order, pre-order and post-order in the last class. Today we will discuss the more features. Okay, so let us start presenting first. No need to put your attendance with messages. I already started the automatic attendance system by Google Meet. So the people, when you are joining and when they are leaving, all these things should be recorded, right? So this is final. So you have to stay connected for the entire session. Okay. Otherwise, you will not get attendance. I will not consider your attendance, whatever you are writing, you are sending as message, right? Maybe I may ask from you, from the seer, to verify, okay? And I will verify it with my attendance, which has been recorded by the system. So don't send messages. Okay. Anyways,
Today we will continue our discussion on tree.
The screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Today we will start the new feature of tree and a different kind of a tree. Apart from this binary tree, as we know that we always dealt with the maximum two nodes of our node from a parent node. What is there in the binary tree, and binary search tree is binary tree with a special property, right? That all this we discussed in the earlier class. Now AVL tree. AVL tree is a new kind of tree. Here AVL stands for this with these three inventors, Adelson, Welsky, and Landis, right? AVL trees. AVL tree is a tree with a special feature that all the nodes will be assigned to a factor which we call the balance factor. Right? And how do you measure this factor? How do you assign the factor of each and every node? We will discuss. It's very, very important for your exam, I repeat. So you have to concentrate fully, right? So you can see this is a tree with certain key values, okay? The different nodes. It is non-increasing manner and it is in non-decreasing manner. Okay? Anyways, the factor, we call it balance factor. It depends on the subtree, level of subtrees of both the sides of a particular node. Level of subtrees, level of both the subtrees, left side and right side. The labels of both left and right subtrees for a particular node from where the nodes have been emerged. Okay. For example, say this is a subtree. It's balanced. Why? The left subtree and right subtree is at the same level, right? For this B node, For this node, there are no subroutes. For this C node, there are no subroutes. Okay. For this C, let's say, why it is non-balanced? For this C, the left subtree and right side, there are no right sub, there is no right subtree, but left subtree has the label, label 1, 2, right? B at the first level and A at the second level, right? So if we apply a rule that balance of the left subtree means the level of the left subtree minus the level of the right subtree, we will get for this C node, we will get 2 because the level of the left subtree is 2, first level, second level, and level of the right subtree is 0, right? Isn't it? Are you getting? Hello? Concentrate.
Yes, sir. Yes.
There are no nodes in the right side of the C node. So the level is 0. Here, 2 levels we can see from this for the C. So 2 minus 0 for this particular C node. So it has the factor 2. It is assigned as the factor 2. Now for this B node, just concentrate on the B node. B has only left child, but no right child. So one level is there, only one level, and there is no node in the right part of the B, so 0 level, right? So left minus right, 1 minus 0, so B is assigned as the level 1. For the A, left minus right, no left child, no right child, right? There is no level, so 0 minus 0 is 0, fine. So A is assigned with the factor 0. So these are called the factors. You can see these are not balanced. Why it is called not balanced? Why it is called balanced? That I will discuss later. Now look at the third diagram. Here, just opposite of this. Here, the left subtree minus right subtree. Left subtree has no level. Right subtree for this A has 2 levels. So 2 left subtree minus right subtree. So it must be minus 2, but I am discarding the sign of the factor. I am just talking about the value, right? Just consider the value, okay? Means modular of this. So actually, I will discuss later. According to the rule, it should be left minus right. Left level, height of the left subtree minus height of the right subtree. So for this A, it should be minus 2. But for this discussion, I am discarding the sign. I am talking only about the numerical difference. Okay. Hello. Hello. Are you getting?
Okay, sir. Yes,
So
sir.
for
Yes, sir.
2, this is 1 and this is 0, just like that. Okay. So the rule is for a balance tree, each and every node must be assigned with the factor either minus 1, 0 or 1. Means minus 1, 2 plus 1. This will be the range for a particular node. This will be the range of factor for a particular node. If all the nodes follows this rule, we will say that this tree is balanced, right? Okay, you can see that this is a balance because each and every node has a 0. Okay, this tree is also a balanced tree subtree because 1 and 0. But if I include C, if I include C in this tree, so it will not be a balanced tree anymore because C is having a value, factor value more than 1. Okay, here also A is having a factor value of more than 1. So the permissible factor is -1, 0, or 1. Okay. Then we will say that each and every tree must be assigned with this factor. Then we will demand that tree is a balanced, otherwise it's a non-balanced. For the example of these two subtree. Okay. In the second tree, whatever I have told, it is written here. Okay. We will study the balance factor. I was talking about this balance factor. This one. Height of the left subtree minus height of the right subtree. Just now I discussed this. So if we get a tree as a non-balanced or not balanced, our responsible is to make it balanced, right? For example, let's see, if we rotate this tree, if we twist this tree subtree in right direction, then C will come. If I add the C here, right, it will be a balanced tree like this way. Right? If A, if I twist, if I twist this subtree, okay, in the left side, left rotate. If I rotate this in the left side, means A will come here, then it will be a balance. So with this, sometimes left rotation or right rotation or left right rotation or right left rotation, we have to make a tree balanced, right? Okay. So this is our job.
Sir.
Okay. Yes. Yes.
Sir, numbering ta kiভাবে হয়েছে একবার বলুন?
Numbering ta. Numbering হচ্ছে numbering difference between the left subtree and right subtree. It's difference between the left side level and the right side level. Okay, this height, level means height and level is same. Like say this has the height 1, this C has the height 2, B has the height 1, right? Okay, so C has the 2 levels, so height is 2, but 0 in the right direction, so 2 minus 0 is 2. Got it? Hello?
Yes sir. Sir, এই ব্যালেন্স সিস্টেমে তিনটে 0 0 0 কেন?
হ্যাঁ, left minus right. Left subtree has the level 1, right subtree has the level 1. Means height of the left subtree is equal to the height of the right subtree. That's why something 2 equal value becomes, if I subtract, it becomes 0, isn't it? B has
Yes,
one left node and one right node. So B has the left level 1 and right level 1. 1 minus 1, 0. A is also no level, so 0, 0, 0 minus 0, 0, 1 minus 1, 0. Got it?
yes sir.
Hello.
Yes.
It's very easy.
Yes.
I think to understand. Is it clear?
Yes sir, clear sir.
Clear or not?
Yes sir, total clear.
The balance factor is this. Okay. Now, AVL tree. To balance itself, an AVL tree may perform the following 4 kinds of rotation. I told you that these will, if we get any tree as not balanced, we have to make it balanced. So there are some rules, some techniques to balance it. Either we will go for the left rotation or right rotation, or left right rotation or right left rotation, right? The first 2 rotations are single rotations, left rotation or right rotation. But this is the combination of 2 rotations. First left rotation, then right rotation. Okay. Fourth one, first right rotation, then left rotation. Right. These are the rotation of the subtree of a particular tree. Okay. To have an unbalanced tree, we at least need a tree of I2 to have an unbalanced tree, right? With this simple tree, let's understand them one by one. See, this is an unbalanced tree. Why? Because our node is having a factor more than 1, 2, you can say this is indicated in the red color. Got it? So this is not, this factor is making the tree unbalanced. So we have to balance it. I told you that if I rotate this tree in the left side, right? So A will come here, isn't it? I am rotating this. I am rotating this in this way. So if I do this one, then
So
it
today we
will,
will continue
A
our
will come
discussion on
at
tree,
the left side of B,
a new
this,
feature of tree.
then this
So
will be
far
a
what we
balanced tree,
discussed, that
right?
is
Each and
the
every node will be assigned
basic features
by
of
the
the tree. How many
permissible factor
trees?
value, right? B is 0 in this. Got it? So it is an example of left rotation. With the left rotation, we can make this unbalanced tree a balanced tree. Got it? Right rotation, just opposite of it. For example, this is a tree with the factor value of C2, so this is a not balanced, unbalanced. I told you that each and every node must be having maximum factor, balance factor 1. Okay, it may be -1, 0 or 1, but not more than 1. Here we got a 2 for this for a node in this tree C. That's why it is a not balanced or unbalanced tree. We have to make it balanced, right? So what we do, if we rotate in the right side, right? If we go for the right rotation, then C will come right side of the B, and then we will make this balanced. We'll get a balanced, right, from this unbalanced. Got it? Okay. Left right rotation, double rotation, a slightly complex version of already explained in the version of rotations. To understand them better, we should take note each action performed by rotation. So here, each and every step is mentioned, right? We'll start. So this is an unbalanced tree. We will go for the left right rotation to have a balanced tree. First, what to do? A node has been inserted in the right subtree of the left subtree. Right subtree of the left subtree. This makes C unbalanced here. After this, why the C is assigned with an unbalanced factor? Because what happened that it is the that node has been inserted into the right subtree, means B has been inserted in the right subtree of the left subtree of C. Left subtree of C is A, right? And right subtree of A is B. So this is actually what we are talking about, this B. So our node B has been inserted in the right subtree. This is the subtree of CA. So right subtree of A, B has been inserted in the right subtree of A of the left subtree of C, right? This makes C an unbalanced node. This is a scenario, so we have to make it balanced. So what we are doing, we first perform the left rotation on the left side of C, left rotation on the left side of C. So left rotation, A will rotate in the left side and B will also rotate in the left side. So B will come here, A will come here. Okay, so left rotation. So B will come here, A will come here. Okay, got it? Hello, are you following the diagram?
Yes, sir. Yes.
Particular subtree of this tree, discarding this C. Okay, we are only concentrating on A and B. We are rotating A on the left side and B also on the left side. So B will come here, A will come here. So this, so we get this. Still, the tree is unbalanced because C is still assigned with the 2, balance factor 2. Note C is still unbalanced. However, now it is because of the left subtree of the left subtree. Now our responsibility, if we now making B the root node of the subtree, C now becomes the right subtree of its own left subtree. So now we will rotate the C in the right side. So first left rotation, with the left rotation we are getting this subtree, and with from this subtree, if we rotate this one, but this C in the right side, then we will get this one and this. Now the tree will be balanced. So this is an example of left-right rotation. Left-right rotation. Got it? So if you are asked that describe the left-right rotation for an AVL tree to make it balanced, okay, with the diagram, then you will just write these answers. Okay. With the example, considering this example, we will start with this. Considering the example, okay, you will just start with this diagram, then step by step you will describe. Okay. Now right left rotation is just opposite. So considering an example, A makes the tree unbalanced, right? So right left, we will first rotate the right side. C, just opposite of the previous diagram, we will rotate this subtree the right side. So C will come here and B will come here. So we will be getting this. Okay, still is unbalanced. This is unbalanced for this A. Now right left. Now we will make a rotation on the right side. So B will come here and A will come. B will come here. This is balanced. This is an example of right left rotation. Okay, first we go for the right rotation, then we will go for the left rotation. Okay, very easy. Completed. So this is all about the rotation, 4 types of rotation to make an unbalanced AVL tree balanced. Got it? Any question up to this point? Any?
Sir, one thing. Sir, the notation can be from -1 to +1. So which type of that subtree will have that -1
Rotation,
notation?
wrong statement. Rotation cannot be -1 to +1. No.
Sir,
Minus
notation.
no.
No.
Notation.
Yes, sir.
Ah,
Yes, sir.
for this, for what? This. Is this
Sir,
example?
sir, you said that it will be from -1 to +1 for a balanced factor, means balanced
Hmm.
tree. Then
Hmm.
which part of that tree will have that -1? Because everything will be in positive, that 0,
It
1,
has
2,
no,
or
it has, no, no, the tree, so it varies. It depends on the structure of the tree. It has no node which, where from where we will get a -1, right? How will you get -1? It's very easy. Right, say, let me, for example, -1. Say, if we get another child from this, let's say D, got it? Let's say C has
yes, sir.
right child, got it? Okay. Now you calculate which will be the factor of B, height of the left subtree, and means height of left subtree 1, and this 1 2. So 1 minus 2, it will be -1. Got it? If I put a right child for this C, so B will have a balance factor -1. Got it?
Sir,
Yes,
if
sir.
you use pen, then it's better.
Okay. And see, each and every node, A will still have 0, B will have -1, and C will also have -1, because 0 -1. No left child, but there is a right child of C. So C will have -1, B will have -1, A will have 0, and D will have 0. Right? Whatever you are talking, but still we didn't discuss that kind of tree where at least one node will be having -1. I told that the uh, I told that each and every node must be having either -1 balance factor or 0 or 1. So far, the trees, what we have explained with, we can see that 0 or 1 is getting, but -1 may come. Then also we will say that tree is balanced. But we have not discussed that kind of tree where we will get a -1 for a particular. That's why I told you, if you consider this tree, the C, this tree, like I just add a node here, right? Then you will get a -1. Clear? Hello? Santon?
Yes, sir. Yes, sir.
Or,
Yes, sir. Clear.
or some confusion is still there?
No, sir. No confusion is there.
We will discuss a lot of tree in the coming classes. Whenever we will discuss the previous year questions on tree, you'll get a lot of questions from tree. So that time you'll see the many tree may have the -1 for a particular one or two nodes, right? Okay. So our what we have to check that the balance factor must be within the range for all the nodes. Range is -1 to 1. It may be -1 or 0 or 1, but not less than -1. -2 will not be allowed, or +2 will not be allowed. Okay. If we get that kind of tree, we will claim that the tree is not balanced. We have to make it balanced. How we can make a tree balanced from an unbalanced form? This is the 4 techniques we have discussed: left rotation, right rotation, left right rotation, and right left rotation. The last 2 are the conjugal rotation. Okay, combination of 2. Got it? Clear? Hello? Clear?
Yes, sir. Yes, sir. Clear, sir.
So we will discuss so many problems on these, right? Whenever you will be solving the problem, when you will be doing by yourself, you will feel confident about this, right? So actually, these are called the balance factor, right? Balance factor. Factor means balance factor. It's balance factor. Okay. One asked how this number we are getting. These numbers are called the factors or balance factor. Got it? Okay. So it's completed. Rotation part is completed. Now another discussion I will uh, discuss and conclude the today's session with the spanning tree. I think all of you have heard the spanning tree, no? When you have studied the graph in your mathematics. Hello, have you heard that this type of tree, spanning tree, the graph?
No, sir.
No, sir.
No, you have studied graph, no, in mathematics.
Yes, sir.
Hello, yes or
Yes,
no?
yes. Yes, yes, sir.
Graph was there in
Yes, sir.
mathematics, no? So just use answer vehemently. Why are you uh, getting so um, ashamed? Graph was a chapter. Well, graph was a chapter in your mathematics subject, na? In the first year, or isn't it?
Sir, no,
Hello.
it was not in the first year, sir.
It was in your HS syllabus. Then
Sir, from mathematics.
graph.
That
Where you have studied graph?
Sir, in mathematics state.
In 10th class.
Yes, sir.
Shanta? It was in your 10th class.
Sir, for us it was not in class 10. We actually studied about bar graphs, line graph, pie chart, that things only.
Okay. Anyway, study in mathematics also this graph. Graph is nothing as a collection of some nodes connected in a particular manner. Okay. A spanning tree is a special type of graph. A spanning tree is a subject of graph G, right? Which has all the vertices. Vertices you can consider these vertices as the nodes, right? Means the nodes of a tree you can consider vertices, but why it is vertices? These graphs are connected. What is covered with the minimum possible number of edges, since a spanning tree does not have a cycle and it cannot be disconnected. Right, yeah, whatever we discussed about tree, these are not, this is open, it's not closed, open. Okay, so no cycle is there, but tree is spanning tree is a special type of tree where the nodes will form a closed graph, right? Let's say this A is connected to C, C is connected to B, B is connected to. No, there will be no open site, right? So it will be closed one. Got it? So this is called a graph. Now, actually, graph, as I told, that graph is a collection of nodes where each and every node is connected with other nodes. Okay. So no closed means path. There will be no closed path. Got it? Path means from A to C, C to B. This is a path. Relate path. These are all the paths. So no open path will be there. The paths will be closed. But spanning tree is that a spanning tree is a subject of graph G, which has all the vertices covered with minimum possible number of edges, Hence, a spanning tree does not have a cycle and it cannot be disconnected. Means all the nodes will be connected, but it will be not be closed one. Got it? I repeat, a spanning tree is a subset of graph G which has all the vertices covered. All the vertices will be there. We will not discard any vertices or nodes. All the nodes will be there, but we have to make sure that edges will be connected in such a way that our cycle should not form. If we connect this one, this will not be a spanning tree, this will be a graph like this. So if we discard, if we cut it, so the nodes are connected, A, B, C connected, right? But it will not be a cycle. So it is one type of spanning tree. So I can emerge a spanning tree from this graph, this number one. I can also draw this way also I can draw this graph and it will form a spanning tree. I am cutting this, I am disconnecting this, so it will not form a cycle. Here also I am disconnecting this one, this path. So the graphs are connected, but it will not form a cycle. Got it? So spanning tree is a graph where the nodes will be connected, but it will not form a cycle. By this definition, we can draw a conclusion that every connected and undirected graph G has at least one spanning tree. A disconnected graph does not have any spanning tree as it cannot be spanned to all its vertices. But disconnected means if we disconnect, so at least one or two nodes will be discarded, right? So we have to disconnect the paths in such a way that no nodes will be disconnected. Nodes will be connected, but it will not form a closed graph or cycle. Got it? So three kinds of spanning we can generate from this graph. So you may get a question that draw all types of spanning tree for this graph. Got it? Hello, it's very easy.
Yes, sir.
Have you
Yes.
understood?
Yes, sir.
Have you understood?
Understood, sir.
Yes, sir.
We found three spanning trees of one complete graph. A complete undirected. Undirected means there will be no direction. Okay, means the signal can move bidirectionally. A can send a signal to B, or B can send a signal to A. Had it been directed, right? So only in a particular direction we will see this. The path will be in a particular direction. Okay, the directed path. It is non-directed. So direction we will not consider the direction. It is called undirected. Okay. So spanning tree is valid for the undirected
Yes.
graph. Okay. So a complete undirected graph can have maximum n to the power n minus 2 number of spanning trees, where n is the number of nodes in this above address sample, n is 3, number of vertices 1, a, b, c, n is 3. So 3 to the power 3 minus 2 is 1, 3 to the power 1. So 3 spanning tree we can generate. So this is the formula. From the n number of nodes in an undirected graph, we can generate the number of spanning tree n to the power 8 minus 2. Okay, got it? So this is the formula.
Yes, sir. Got it, sir.
Okay. Had been 4, then 4 to the power 4 minus 2 means 4 square, 16. Had been 4, number of vertices 4. Then how many number of spanning tree can generate? 4 to the
16.
4 minus 2 means 2, 4 square, 16. Okay, you can test it by yourself. Okay, let's say I had been a square. Okay, make it a square, A, B, C, D. Now you try to find out the number of spanning tree, right? So if you miss one or two, you will understand that you have to count whether it becomes 16 number of spanning tree or not. If not, then you will understand that you have missed a particular pattern, right? Got it? So this is the
Yes.
okay. The general property of spanning tree is a theoretical question. You can study. A connected graph G can have more than one spanning tree. All possible spanning tree of graph G have the same number of edges and vertices. The spanning tree does not have any cycle or loop, right? You can also call a cycle as loops. Removing one edge from the spanning tree will make the graph disconnected. The spanning tree is minimally connected. Here, this disconnection for the loop or cycle, not disconnection of a particular node. All the nodes will be connected, but you have to disconnect the path in such a way that it doesn't form a cycle. Got it? Okay. So this is
Yes.
section we are talking about. Mathematical properties of a spanning tree. Spanning tree has n minus 1 edges. Right? You can see here number of nodes 3, so we are getting 2 edges. Right? First one is this. A spanning tree has n minus 1 edges, or n is the from a complete graph by removing maximum e for edges, e minus n plus 1 edges, we can construct a spanning tree. A complete graph can have maximum n to the power n minus 2 number of spanning trees, what we have discussed here. Okay. Okay. Now, so you will just study all this, you will get a questions, theoretical questions from this spanning tree. Application of spanning tree. These are the application: civil network planning, computer network routing protocol, which you will study in your computer network when you study in computer. I think it is in your 4th year, right? Computer network is subject. You will study a lot of protocols which to maintain the connectivity of data from one point to another point, from one computer to another computer. So to transfer the data, we are supposed to maintain so many the protocols, right? Cluster analysis. Cluster analysis also means cluster means collection of nodes having the similar property forms a cluster, right? Mainly this cluster concept you will study if you study these telecommunication. I think telecom is you're supposed to study in 3rd year or 4th year. I know there must be a particular subject on your electronics and communication engineering where you have to study about the telecommunication, mainly the wireless network, right? Got it? And I think digital signal processing also you will get this term cluster. Okay. Minimum spanning tree. In an weighted graph, a minimum spanning tree, a spanning tree that has minimum weight than all other spanning trees of the same graph. In real world substitution, this weight can be measured as distance, congestion, traffic load, or any arbitrary value denoted to the edges. So minimum spanning tree we will discuss later. Minimum spanning tree only valid for the weighted graph. Weighted graph means each and every path must be assigned by a weight. Let's say you may consider this distance, right? Hello, the distance. Say A and all the nodes will not be connected to the same distance. So path
Sir,
assigned to a value of this. Yes.
sorry to interrupt. স্যার আমাদের এরপরে আবার 2:05 থেকে ক্লাস আছে স্যার।
2:05 থেকে?
হ্যাঁ স্যার, এখন অবধি
আবার
লাঞ্চ
আমার একটা আছে না lab?
কিছু হয়নি।
You are also having a lab from 3 p.m. right?
3 p.m. Yes sir.
So back to back class we have. Okay, let us conclude this today's discussion and let me check out. It was almost completed. Almost completed. Okay, just a minute. Just a minute. Okay, so we will continue with this from in the next class. So let us conclude
Okay,
this
sir.
today's discussion. Okay.
Thank you sir.
So, bye. Okay.
Thank you, sir.
Thank you, sir.
Okay.